All right, I am here. We're working on systems of equations elimination method, and we are on what I would consider the hardest of the hard problems. Obviously, it doesn't have decimals, so it's not really that hard, but the harder of the four options that there are. So elimination requires you to do kind of a different situation. You're trying to eliminate one of the two variables. You get to choose which one you want to use, and sometimes some of them are harder than others. And this is probably one of the harder types of problems because you do have to change both equations to eliminate one of the two variables. So in this option, we're looking at the variables. We look at the x's. There's no easy way to do this. They are set up correctly, right? So x's are on top of x's, y's are on top of y's, constants are on top of constants. We don't have an opposite pair though. So I can't eliminate just by adding the two numbers together and getting rid of the x or the y. Neither of them is the exact same either, which is your next level of ease, because if there's one that's positive and one that's negative, it's easy to eliminate. They're both the same, then you got to do a little bit of changing. But when there's no continuity or anything in common easily, you're going to have to do what we have to do here, which is to change both equations. So looking at this, the easiest thing I can think of, I do see 5 and 3, we can multiply to get 15. So we're going to stick with that because I think that's the easiest of the options. One of them's got to be positive, one of them's got to be negative. You get to choose which one you want to be which. I'm just going to go with the top one being positive. So if I multiply the top by 3 times 5x would give me the 15 that I'm looking for. But then down here, I'd have to multiply this bottom equation to get negative 15 by multiplying by a negative 5. So now what I'm going to do is I'm going to go ahead, next to this, rearrange the whole equation and rewrite it so that it multiplies everything on the top by 3. So 3 times 5x is 15x. 3 times 4y is 12y. And then 3 times a negative 30 is going to be negative 90. The lower numbers that you can find, the easier this will be because you don't want to deal with really extreme high numbers or anything like that. Now I'm going to go ahead and do the bottom. Negative 5 times a positive 3x is going to give me the negative 15 I was looking for. Negative 5 times a negative 9 is going to give me 45. It's going to be a positive because it's negative times a negative. And then our last one is a negative 5 times a negative 18. And when you do that, again, it's going to be a positive. In this case, it's going to be a positive 90. So now I'm all set. I can add together to get my values. The 15x plus the negative 15x, that's canceling them because they're opposites. Now I'm going to go ahead and I'm going to do the addition of the other ones. So we have 12 plus 45y. You're going to get 57y. Move this back a little bit so you can see that. Sorry if it gets all blurry. And then here you add these together. They also give you a 0 pair. So you're going to end up with 0. Don't panic. Do your normal steps. Divide both sides by 57. Y is equal to 0 divided by 57, which is just 0. So you now know 0 is what y is. So now you're going to go back, pick whichever one makes you happy. Go to the original equations, and you're going to substitute in 0 where y is. I'm just going to use the top one. 5x plus 4 times the y that we just said was 0 equals negative 30. Now this, again, you're probably getting alarmed by this because you're probably like, oh my gosh, you're not supposed to have that. It's okay. If you're worried about it, don't worry about it. 5x is equal to, this is 0 because there's nothing else there, negative 30. And then you're going to divide both sides by 5, and you're going to get x is equal to negative 6. Now again, double check this. Make sure that your x and your y, when plugged into the other equation, we know that it works for this first one because we just solved to get this. So we know it works for the top. If I'm checking this, negative 6 times 30, that's going to give you negative 18. Y over here times this, negative 9, is going to give you 0. So negative 18 is supposed to equal negative 18. Does it? Yes, it does. So my numbers work. They are correct. And my answer in coordinate form is -6, 0, and that is my answer, and that's what I've got. If you want more questions like this, you may find them in my YouTube channel, U1 Algebra. Check all of these and so much more out in the Systems of Equations Elimination Method section.